All right, so here we go with section 9.3, part 2. We're still working with that normal curve, but in this session, we're going to take a look at using the normal curve to calculate probabilities. Okay. Now, the idea here is pretty straightforward, pretty simple concept. I have algebra, which is the function here, and I know that that function is a probability model for some scenario. I know that the area under that curve is going to be the probability for a given range of values. And so if I want to know what the probability of something is, I just need to find that area. Okay? In order to find that area, I need to know three things. I need to know a lower limit, I need to know an upper limit, and I need some sort of function for that guy. And so I would say that the area there, the area for that piece of the pie is the integral from a to b of some function f of x dx. And that's going to be the probability that a is less than or equal to our random variable x is less than or equal to b. I just need to do this. Here's where things get ugly. This isn't something that you can do, because if you remember, in order to do that, I need to be able to find this. I need to find the antiderivative and then evaluate it from a to b. The problem is the algebra necessary to turn our little f, our algebra for that curve, into that big F, the antiderivative so I can evaluate, is beyond the scope of what we can do in here. So what we're going to have to do is we're going to have to rely on some sort of technology to help us out. Right? First things first. Right? Here's the logic and the rationale behind it. Right? A standard normal distribution, standard being a modifier, is a normal distribution that has a mean of 0 and a standard deviation of 1. The area under the curve is still equal to 1 because it's a probability model, but all we're saying is that the middle is 0, so that means that our mean is 0, and that the inflection points, if you want to think about it that way, are there and there, or that the standard deviation, the sigma, is equal to 1. Okay? As soon as I'm talking about a standard normal, though, something changes. Right there, that's what changes. Did you see it? The horizontal axis is no longer the random variable x. The horizontal axis is now the random variable z. And why z? Because I'm working with a standard normal distribution. Okay. Since I need to find areas, and since the algebra necessary, the calculus necessary is beyond what I can do, I'm going to have to find a way to get life to work for me. And here's how I'm going to get life to work for me. I'm going to take every value from my normally distributed random variable x and turn it into a z. And when I turn it into a z, what I'm technically turning into is called a z-score. Right? So if I have some normal distribution over here, like we had for the kids in school, and let's say that I knew that my middle was what those kids scored on that math test, which I said was approximately a 305. And let's say that my standard deviation, I think you said it was 45, right? And let's say that for whatever reason, I want to find the probability that a kid scored more than 310 on this test. That means that over here somewhere, there's a 310, and I want to find all of that area right there. Now, I know what that means to do. That means set up an integral, but I can't do that. So what I'm going to do is I'm going to change this from just some random variable x, and I'm going to change this into a standard normal distribution and find a z-score for my stuff. And then I'm going to go here, and I'm going to look things up in this table. Okay? So let me just show you what that looks like. Okay? I'm going to take my random variable value x, and I'm going to turn x into a z-score. Right? And so then the way I turn x's into z-scores is I use this formula. And so I'm going to take my 310 minus my mean of 305 divided by my standard deviation of 45, and I'm going to say that's my new z-score. So 310 minus 305, I don't even know why I'm using a calculator for that, 5, divided by 45, and I get a z-score of 0.1 repeating. So that same value over here and the same tail over here would just mean to find a probability where z is greater than 0.1 repeating. And why do I use z's? The reason I use z's is I have a table of z's. And here is my table of z's. You'll see that I have all of these z's and I have associated a's. The z is the z-score. The a is the area. Right? The only challenge I have is, and unfortunately there's no way I can get around this, is my z-table is a left tail table. Meaning that what this thing does every single time is if you give it a z-score, it finds the left tail. That's not what I want. I want the right tail. So I'm going to have to use that trick that we used before, where our right tail is just 1 minus our left tail. All right, so my job was, and I'm going to go back over here and see, my job was to find out what was the probability that a kid scored more than 310. The way that I'm going to do that is I'm going to find the corresponding z-score and find the right of that. My corresponding z-score is 0.1 repeating. I want the right tail. My table is going to give me the left tail. So I'm going to go ahead and find that on my table and then use my left tail to find my right tail. All right, so I'm going to come back over here and I'm going to look for a z-score of 0.1 repeating. Okay. You notice these are all negative z-scores, negative z-scores, negative, so it's not here. Keep scrolling until I find it. Ooh, these are positives now. Ooh, there's a 0.11. That's probably as close as I'm going to get. And that 0.11 gives me an area of 544, 543,795, 543,795, 543,795. So this left piece here is, whoa, 0.543,795. And if the left is 543,795, what's the right? Well, then this piece over here is just 1 minus 0.543,795, which would be 0.456,205. But if the 45, we'll call it 46%, is the right tail here, then it's the same over here. Or the chance that the kid scored a greater than 310 on the math test is 46%. Now that's how we would do things if it was 1950. But we don't use these things anymore, right? Technology made this obsolete. I don't need this. In fact, this thing makes me sad. I don't want to use that table anymore. I don't want to look things up on a table. I don't want to have to take every single one of these problems and turn an x into a z and then turn a z into a value by looking it up in the table. I want to use technology. So I'm going to do a bunch of examples here. I'm going to show you how we can use technology to find these. Now, there are only 3 problems that we're ever going to do. Left tail problems, right tail problems, and a strip in the middle. So do you see how right here on the screen are all 3? Left tail problem, right tail problem, and a strip in the middle. Okay? Now, if I wanted to correctly write out this first problem up here, I'm trying to find the probability that z is less than or equal to negative 1.30. Now, how do I know that it's a z and not an x? Because my axis isn't labeled here. The answer is right there. As soon as they say it's a standard normal curve, it's a z. All right, so that's what I want to do. Now, I could go here and look it up. I could come back up here and find negative 1.3. Where's that going to be? Oh, there it is. And I can say that that area is 0.09680. Right? But I don't want to do that. I don't want to have to look it up. So I'm going to prefer to use some technology. So I'm going to use my technology. I'm going to go to my distribution menu. The same place we went when we found those binomial PDFs and CDFs, and we're going to use that. Except for now, we're going to use the second command here, the normal CDF. Okay? It's the normal curve, and it finds the probability for a range of values. I'm going to punch that command up, and it's going to bring up this or something that looks similar to this. Okay? If you happen to be using an 83, it'll look different, and I'll show you what to do in a moment. Okay? For us, we're going to put in a lower limit, an upper limit, a mean, and a standard deviation. The problem is I don't have a lower limit because in my picture over here, this just goes to infinity. So what do I do if I don't have a lower limit? Well, I'm just going to type in a stupid big negative number. Because of that horizontal asymptote out there, sooner or later it's going to get close enough that it doesn't matter. So I'm just going to put in a stupid big negative number. And then my upper limit will be that negative 1.3. My mean is 0 because it's a standard normal curve. My standard deviation is 1 because it's a standard normal curve, and I'll paste that back in. Now, if you happen to have an 83, normal CDF, lower limit, comma is right above the 7, upper limit, comma, mean, comma, standard deviation. So I'll write that out over here for you. Normal CDF, lower limit, comma, upper limit, comma, mean, comma, standard deviation. And when I press enter, I get this, negative 0.096800549. Is that what we got over here on the table when we looked it up? Is that the same value? .09680096800. We're off a little bit there because wouldn't that round to a 1? Wouldn't that be a 1 right there? Uh-oh. Looks like we're off by, on the table here, what is that going to be? Tenths, hundredths, thousandths, 10,000, 100,000. We're off by like a millionth or so. I think I can live with that. All right? This is how we're going to calculate these probabilities. All right? What's the difference between problem number 1 and problem number 2? Well, problem number 1 was a left tail. Problem number 2 is a right tail. I'm still going to do it the same way. I'm told it's a standard normal curve. Now I just want to find the probability that z is greater than or equal to negative 1.30. Right? Now, just for fun, this was 0.09 something. I forget now. 0.096801 rounded. Right? Those are complements, aren't they? So the answer should be 1 minus that. So my answer should be 0.9031994506 or something like that. So I'm going to go and check to make sure I can get this right. Normal distribution, normal CDF. I now have a lower limit of negative 1.3. I now have I don't have an upper limit, so I'm just going to put in a stupid big number. I still have a mean of 0 because it's a standard normal curve. I still have a standard deviation of 1 because it's a standard normal curve. I'll paste that back in, and what do I get? 9031994506. So 0.903, round it wherever they tell me to round it in the problem. Problem number 3 is the strip in the middle problem. So again, I want to find the probability that negative 0.45 is less than or equal to z is less than or equal to 2.11, because I want from there to there. Okay. I go to my distribution menu, normal CDF, lower limit of negative 0.45, upper limit of 2.11, mean of 0 because it's a standard normal curve still, standard deviation of 1 because it's a standard normal curve still, and I get 0.656, round wherever they tell me to round it to. Okay? All right, when you're working on the homework and you do these problems, if you click on the help me solve this or show me an example, they are going to take you down the rabbit hole of going to the table and solving this problem using the table. Please don't do that. Okay? All right, moving on, number 4 here. Find the area of the indicated regions of the standard normal curve. Oh, this is a left tail and a right tail problem. So one way that I could solve this is I could find that left tail, I could find that right tail, and then I could just add them together. Like, let's say that that was 0.2, and let's say that that was 0.15. And then I would say, okay, add them together and you get 0.35. Another way that I could find it is I could find the middle piece and subtract from 1. Like, let's say that this was 0.6. Well, if that's 0.6, then the rest must be 0.4, because since it's a normal curve, a standard normal curve to be specific, the area under it must always add up to 1. Now, me personally, I'm lazy, so I am going to do it that second way. I am going to find first the probability for negative 1.13 being less than or equal to z, less than or equal to 2.03, and that's going to give me that middle piece, and then I'll subtract from 1. So I'm going to go to my distributions. I'm doing that normal CDF. My lower limit is negative 1.13. My upper limit is 2.03. My mean is 0. Standard deviation is 1 because it's a standard normal curve. And I find that that middle piece is 85%, around wherever they tell me to round it. So how about 8, 4, 9, 6? So then what are the two tails? Well, there's going to be 1 minus that value, and I get 0.15. So then the sum of those two tails is 0.1504, round wherever they tell me to round it. Right? So basically what we're going to be doing the rest of chapter 9 is those 4 problems again and again and again and again and again. You're either going to be finding a left tail, you're going to be finding a right tail, or you're going to be finding a strip in the middle. And then the last one, of course, depends on how you see it. Is it find a left, find a right, and then find the complement, or sum those together, or is it a find a strip in the middle and find the complement? And both ways work just fine. You just have to decide what way works for you. All right, we are currently sitting at 18 minutes. I'm going to stop this video here, and I'll come back and make another one where we'll move on through these problems.